Hello everybody, and welcome back to Space Engine. I'm just hanging out near Saturn because I was doing something earlier, but we can carry on with what we're doing now. Alright, let's start off by going to locations. Control V. This one is a very large one. Does it exist? It does exist. Apparently it looks very much like Earth. So, let's check it out. I mean, yeah, it has rings, which are nice. Visually it looks pretty Earth-like. Let's look at its information, shall we? Actually, wait, where is it? Like Earth, ESI 0.972. Yeah, that's pretty close. Its atmosphere is... Actually, that's actually pretty close. It's like a, 0.23 more than Earth, so not very much. Temperature, pretty close. 47% nitrogen, 33% oxygen, so it has richer oxygen than we do. We're 70% nitrogen and 20% oxygen. And then it has a fair bit of water in its atmosphere. Very moist planet. 1.1% CO2, 644 parts per million of sulfur dioxide, and then argon, neon, krypton, and carbon monoxide. Interesting, interesting, interesting. What is the hydrosphere like? 100% water. Good. Alright, well, it is a very nice place. I'd live here. Although it seems to already have life forms on it, so, best to leave them alone. Alright. Let's carry on, shall we? That's what I'm gonna have to type. It's another long one, but whatever. 8. I'll use the number pad. 849 dash 509 dash 8 dash 52. That wasn't a 2, that was a 0. And how come these aren't working? What did I do wrong? I'm very good at this, as you can probably tell. What the hell? Oh, my numlock wasn't on, so it was causing problems. Well, that was grotesquely confusing. Yeah, okay, there we go. It's a new keyboard, I forgot that happens. Because I was actually just getting a new mouse, but I wanted a wired mouse, not a wireless mouse, because I hate wireless mice. I find them irritating and annoying. And it's hard to find wired mice that aren't like the expensive gaming ones by themselves. 415. So this one came with a keyboard, and it's a nice keyboard. It's actually smaller than my last one, which I kind of like, because the last one was getting old. Does it even exist? It does exist! Yeah, the one I had was the Alienware keyboard that came with my computer, and like, it was a good keyboard, it just... Eh... It was kind of big. Kind of clunky, and it was having problems. Yeah, that's a white dwarf, alright. And it seems to be an active one at that. Yeah. You can see it has a debris disk. It has a dark debris disk, and then a lighter portion in here. And it has jets coming out of its poles. So it is a very unhappy star. No, not... God damn it. Looking for... No. No. Oh, where the hell is... Time? No, that's magnitude. There we go. What, does it not work? Oh, there we go. Yeah, it's just debris falling in. Interesting. Cool. Wait, so much more place I need to go. Yeah, oh wait, there's labels still on. Ooh, orbits. Oh, I have to sneeze. Ah. Yeah, excuse me. Alright then. Well, yeah, white dwarf. They are pretty neat. Ooh, look at that. And its little companion, which is a red dwarf. Frigid air Aquaria, cold mini Jupiter. Let's go there. Why not? Well, that's nice. Alright. And now we're going to a nebula up next. RN 0-1 2 924 dash, I am doing this right? Yes. 10704. Does it exist? It does, so we're going. Boop. Ooh, that looks spooky. I said it's kind of like a bowl nebula, kind of like the Orion Nebula. So I don't know if this looks different than what you saw, but it definitely looks interesting. It has a very Stellar Nursery vibe to it. And we all know how much I love spooky nebulas. Ah, cool. It has kind of like, from the outside, it's all dark and obscured, but then inside it's all like a mission nebula. Let's take a look at one of these stars. A white main sequence binary. Oh, yellow giant. White main sequence. Blue main... Wow, a lot of these are just really hot stars. Oh, there's a yellow dwarf. Just like our sun. Boop. Look at you. What's the age of this? I would assume it's a newer star. Oh, that wasn't helpful. Oh. Alright. It has 10 planets. Nice. Age. Oh, yeah. Neat. I like that. What are its planets like? Ooh. A super Aquaria. Let's go there. Also, the person who recommended this nebula, to answer your question, yes, I have seen the Europa Report. It was actually a very good movie. I enjoyed it. It was kind of a fun little, kind of like a space opera, I guess. How come my mouse isn't doing... Ooh, what's it set on now? Oh, there we go. Yeah, it was fun, you know. People go to Europa, and I'm not going to spoil anything, so that's all I'm going to say. But no, I did see the Europa Report, and I really enjoyed it. And it was a lot of fun. The music for it's really great. I actually used it, the music from it, in one of my KSP videos a few years ago. So, yeah, good times. Where are we at? 8 minutes? 8 minutes indeed. Where even are we? What galaxy? Is this the Milky Way? No, it's just a random ass galaxy. Actually, that would be RAJ or RAG. And I'm funny. Anyways, I guess we can just explore for the sake of exploring. Um, Actually, let's see here. What kind of galaxy do I think this is? From looking at it from the plane. I'm gonna assume it's a spiral galaxy. It doesn't really look like a bard to me, but I could be wrong. Eh, no, well, the nucleus is pretty, like the central bulge is a little blank. It might be a bard spiral. Well, let's find out. Ah, look at that. It is a spiral. Would you classify that as a bard spiral? I don't think it really has. No, it doesn't really have bars. Like the Milky Way has bars. Um, But, well, unless you classified this entire central mass, and then these are the arms, then maybe. A curious little galaxy. Yeah, you can tell the shape by just looking through the plane, which is how we have a fairly good idea of what our galaxy looks like. It is a barred spiral galaxy with, I believe, 4 large arms, and we used to think that we were in what was called the Orion Spur between the Sagittarius arm, but now we're thinking that we are actually in one of the arms, and it's the Orion arm of the galaxy, so yeah, that's kind of cool. Let's look for these blue giants, Wolf-Rayet star. Ooh, cool. Boop. Nice. Wait. Now, I used to know what a Wolf-Rayet star is, but I forget exactly. Oh God, I took like astronomy 9 years ago. You think I would remember these things? And my dad has an observatory, and oh my God, we're on the surface. I'm uncomfortable with this. What's going on? I wonder. Let's quickly do a Google check. That won't stop my... Yeah, the stopwatch is still going. Let's look up what a Wolf-Rayet star is. 'Cause I'm not gonna let this go. Rayet star. Our stars are a rare heterogeneous set of stars with unusual spectral showing, prominent broad emission lines. Yeah. Um. God, it's like I should have known that. Our evolved masses of fusing helium, heavy elements in the core. Weren't they in like what do you call it? That the thing. The Pleiades? No. Hmm. Either way, yeah. They're stars that have very unusual spectra showing prominent broad emission lines of ionized helium, highly ionized nitrogen, or carbon. The spectrum indicates a very high surface enhancement of heavy elements, depletion of hydrogen, and strong stellar winds. There we go. I lose points for not remembering that, but whatever. Let's not land on the star. Ta-da! 34G. Yeah, I should think so. Well, that's kind of fun. What's that? Blue main sequence, white dwarf. Oh, right, my phone. I need to turn the stop. I need to go back to the stopwatch so I can see what I'm doing. Yeah, 13 minutes. All right. Oh boy, today is Canadian Thanksgiving, and I have no interest whatsoever in it. But my brother's coming over, so I have to spend time with him, I guess. And he's not bad, but I just don't care for Thanksgiving that much. Like, I don't eat turkey, so there's no real point. Ooh, a super giant. Boop. Nice. What's the planets looking like? Ah, fun in the sun. Let's go. I like my planets molten and ablating. Yeah, look at that. Actually, this place might be a little less fun in the sun. Still pretty... Ooh. Why is it doing that? Weird. Still pretty warm. Pretty warm indeed. Volcanoes on the surface, because there's always volcanoes on the surface. Not always, but frequently on these planets. But you know what? That's okay. Ooh, what's this? Hot asteroid, hot asteroid, hot asteroid, hot asteroid, hot airless mini Terra. Nice. So basically it's... Okay, please. The controls are not having fun. And now the game is frozen. Why do you do this to me, Space Engine? Well, okay. How long are we going to be here? Nobody knows. I surely don't know. What, is the game just fully... No, no, we're good. There we go. Let's turn that off because that just was a real pain. Surface detail is nice. I do enjoy that. My, look at you. Having sun problems. And some fresh impacts. That's always nice to see. Interesting. The poles are looking rough. Excellent, excellent. Well, let's just carry on then. Haven't found life this episode. Alright, well, went to that one planet that had life. I didn't really find it. I was told to go there, so I don't know if it really counts. There's been some updates on the whole Venus thing. Apparently, looking over some data from Pioneer Venus, they found that the larger probe may have actually detected phosphine, or something like phosphine, when it entered the atmosphere back in the 70s. That's kind of fun. Of course, we can't say for sure until we actually go and check again. That's always fun. Most likely isn't life, but it's still kind of fun to think that it might be. Or kind of like the hydrogen depletion on Titan. That's my favorite one, because it's so spooky, I love it. Or the seasonal methane that may or may not be on Mars. That one's kind of... The jury's still out on that one. Because I see some things where it's like, it's been, you know, it's been detected, then, oh no, it was an error in the instrument. So it's like, Mars is just like that, though. It likes being bullshit. Kind of like with the Viking experiments, which were so uncomfortable, but whatever. Actually, I enjoy the idea of dust plasma-based life. It's like there was this idea, and in 2007, some computer modeling was done, and they found that if you put very fine, uniform dust particles in a plasma field, similar to what we might find in space, the dust particles like spontaneously self-assemble into helical structures, like very tiny microscopic helixes. And these little helixes would, you know, interact with each other, reproduce, like they would break off and form new ones, and over consecutive generations, they would, in a way, evolve to produce more stable and stronger versions. So they're basically like little helical dust crystals that behave like life more than, say, fire does. So there's this idea of if that is classified as life, where, like, you know, if we did find that these things are created and they're classified as life, it might mean that the most common form of life in the universe is plasma-based because, well, those conditions are quite frequent. And although this was a computer model, mind you, we haven't actually seen it, so you can't say for sure. But locations that they might exist in are planetary rings with plasma environments. So Saturn and Uranus pose the best candidates to find these. But if we did find them, they would be very, very small. They would be very, like, their populations would probably be very low. And they would have very long lifespans and life activities. So if they do exist, like, say, in the Saturns of Uranus or the Saturns of Jupiter, or not Saturn, they would be hard to find. but they would also take so long to evolve and change that I don't think they could develop too much complexity. Like, I don't know, like some life just wouldn't be able to develop complexity or intelligence, and I don't think that helical crystals could develop much beyond helical crystals. I mean, maybe some more complexity could arise, but intelligence, or even just thought, I'm unsure. I mean, it is a, um, well, at least I'm of the camp that intelligence and thought are emergent properties of complexity. So I don't know. And even if they could, again, since their like existence is so long, they probably wouldn't evolve. They would evolve very very slowly, basically. So if there are crystal based or like little plasma dust based crystal life around Saturn or Uranus, they're not going to develop into anything that can outmatch us at least for like a trillion years. I don't know. But again, it's such a unique form of life if you want to classify it as life because it isn't organic and it isn't even biochemical. It's inorganic, electromagnetic, ionizing based life. I don't know. It's a very very weird form of life. It's kind of like the those weird cloud and energy beings that are always showing up in Star Trek, and people act surprised when they find them. So, I love the idea, but it would be very, very, very difficult to prove or to find. But I'm all for trying. That's just me. But anyways, that's 22 minutes, so I'm gonna end it here. Thank you all for watching. I hope you enjoyed. If you have ideas for things for me to go to, let me know, and I'll do so. Or even things to talk about. I'll talk about anything. I don't know. I was actually thinking of doing a video where I discuss different like forms of exotic like biochemistry or possibilities thereof, including the plasma life. And I was actually going to, but the recordings kept just not going well because I'm terrible at reading off scripts. But I'll keep working on it. In the meantime, if you want to see stuff on this, look up Melody Sheep. Melody Sheep on YouTube. He does a lot of really, really excellent videos, but he's been doing these videos on the prospects of life in the universe called Life Beyond, and he released one 2 days ago where it's talking about like different forms of like how life could evolve, and then exotic forms of biochemistry, including the plasma-based life, and it's really, really cool. I recommend it. So, thank you all for watching. I hope you enjoyed, and space.